Okay, so we want to find the fundamental, we want to do the fundamental triangle on the x interval from 1 to 3 halves. Where's that interval? Well, it's on the x-axis. We go from 1 to 3 halves. And of course, 3 halves is 1 1/2, halfway between 1 and 2. And given that people, fractions are not taught well in our schools, or in the other courses we use here to prepare people apparently, because nobody can really do them, and we have to know where 3 halves is, okay? And we have to know the fractions, and of course, that's on the worksheets that we started the course with. So we do need to know that, and then we need to know how to locate fractions. And that's kind of a new skill that we might want to address separately. Okay, well anyhow, there's the interval from 1 to 3 halves. Here's 1, here's 2. We go from 1 to 3 halves. So we do the fundamental triangle on this interval. That means we go to the point, the graph point corresponding to this end point of the interval, which is right here. And we know that's the point 1, 1. Okay, and I drew that over here. And then at 3 halves. We don't yet know the coordinate of this point because we haven't done the arithmetic yet, but we want to draw it before we do any calculations, so we do this. And here it is. Looks like it might be about 2, the way I've drawn it here. It turns out it's 2 1/4. Actually, it's 3 halves cubed. It's higher than that, but my graph isn't quite right. Okay, it's over 3. Now, there's our fundamental triangle. We draw it over here. And at this point, I had a question mark on this number here because we hadn't yet evaluated it. We knew these coordinates. We knew this coordinate, but we didn't know this coordinate. And then we addressed the question, well, how do we find this coordinate? Well, how did we find 1 and 1? Well, that was on our table. We took x equal 1 and we calculated the cube because, of course, our function is y equals x cubed. Well, if x is 3 halves, we're going to do the same thing. It doesn't happen to be on our table. Could have been if we'd have wanted it, but it's not on the table of the basic points that we want to think in terms of. Okay, so anyhow, you have x equals 3 halves. So we're on the graph of y equals x cubed, so we better calculate x cubed for x equals 3 halves. And that's 3 cubed over 2 cubed, 27/8. Now, I commented in class that, you should be able to figure out about where 27/8 is in your head without punching it into a calculator. 8 goes into 27 3 times. 3 times 8 is 24, so between 24 and 27, you got 3 left over. So you have 3 3/8. Now 3/8 is a little less than 4/8, which is a half. So you know that this is going to be between 3 and 4 and a little below 3 1/2 if you want to try to locate it on a graph. Now in decimal form it's this, but we're not going to use decimal form. Okay, in the first place you can't, that rounds off to 3.4, and that's about as well as you're going to do on most graphs anyway. The 7375, you're not going to be able to locate that accurately unless you've got a very big, very precise graph. But we're not even going to do that. We're going to say it's 27/8, and wherever that is, it's not accurate. The graph isn't accurate. This point is too far out. It should have been steeper here. That doesn't matter. We're drawing a picture. We're not trying to estimate from the picture. If we're trying to make estimates from the picture, we'll draw a more careful graph. Okay, in any case, the coordinates are these. So the run is from 1 to 3 halves. 3 halves minus 1 is 1/2. Now we can't count that on our fingers. We can count by halves if we wanted to. But we understand that calculation. For the rise is from 1 up to 27/8. That's going to be 27/8 minus 1. And what does that equal? I'll just put dots down here. That's 19/8. Certainly, the very first thing we did the very first day of the extensive worksheet I gave you, you're expected to know how to do that fractional calculation. I'll tell you, it's 27/8 minus 1/8. You get your common denominator. Then you're going to do 27 minus 8 over 8. 27 minus 8 is 19. You get 19/8. And we're not going to take a calculator and do this. If the fractions were, 2401 divided by 125 or something like that, then, that's perfectly legitimate. You can do the calculator. Here, you're just talking about numbers that you can deal with if you know your multiplication tables up to 10. Okay, and if you don't, you need to start using them. You knew them at one point. Too much calculator use, you might well forget such a thing. Okay, well anyhow, the slope then is rise divided by run, which is 19/8 divided by 1/2, which is 19/8 times 2 over 1, which is 19/4. Now somebody said, well wait, that's 38 over 8. Yes it is, and you perfectly well understood, the person that said that, perfectly well understood that 38 and 8 are both divisible by 2. You can reduce the fraction down to 19/4. Okay? So I didn't do every step, but I assume that you can do fractions. Okay, I put this in red. The displacement from A to B, okay? If you got small numbers, you can count from A to B and see what the displacement is. Or you can subtract A from B. You should do both and convince yourself that they give you the same result, so you'll really believe in this subtraction. But this is fundamental. Okay, subtract the coordinate of this point from the coordinate of that point. Now, just a little blurb on the interplay between symbolic expressions and the geometric picture, and how you can combine the two into a deep understanding. We'll do that in the next clip.